Hi all. So today I'll be explaining about principal component analysis and I'll explain how this algorithm works. So this algorithm is basically a dimensionality reduction algorithm. When you have a huge feature space and you want to actually select a few variables or you want to compress the feature space, then we use this algorithm. And the assumption of this algorithm is like there are correlated variables and the collinearity condition, and they are linearly correlated with each other. Okay, so there is a linear correlation, which is the assumption. So there are a few steps which we follow in this algorithm. We standardize the feature and then we calculate the covariance matrix. From the covariance matrix, we calculate the eigenvalues and eigenvectors, and then we sort the eigenvalues in descending order. And accordingly, we rearrange the eigenvectors. Using the eigenvectors, we transform data from the original matrix to the transformed data, and then we pick, let's say, n or k number of eigenvalues, and then we form a eigenvector matrices. So this will help us like how many principal components actually we want to extract from the actual feature space. So I'll just explain these steps in a bit more detail. So when I say we standardize the data, so what we do is we convert this data into 0 mean 1 variance, and for each feature we have to apply this formula where mu is the mean of that data and sigma is the standard deviation of that data. So this will give us the standardized data set. Now we calculate the covariance matrix. So for a two feature, covariance matrix looks like this. The first element is variance of x, then covariance of x and y, covariance of y and x, and variance of y. So for population and sample, these are the formulas. Generally we'll be using the sample formula. Okay, then we calculate the eigenvalues and eigenvectors. I'll just correct here. So what we do is we take a determinant of a minus lambda I equal to 0. So a is the standardized data and lambda is the eigenvalues and I is an identity matrix. So when we pass this through this equation, we calculate the lambda values here. Now for each lambda value, like you will get lambda values equal to number of features here. So each lambda value we pass into this new equation where a minus lambda I v is equal to 0 and v is the eigenvectors. Okay. Now we sort lambda values in descending order and accordingly we arrange the eigenvectors, which is v. Now the feature matrix, we multiply it with the top k eigenvectors. I'll tell you how we select this top k eigenvectors, but this is how we get the transform data. So from our original space, we go into principal component space. Okay. Now to select this, how many k's are required, you can multiply it by the original eigenvector matrices like initially, and then you calculate the covariance matrix of this transform data. Now when you do that, you can calculate the variance of each variable, from where you will get the contribution of each principal component. So let's say principal component contributes 70%. So how you can calculate that? This matrix covariance matrix will look like a identity matrix, but instead of 1 it will have some values. So you can do summation of these values, and then let's say you want to calculate variance captured in first two principal components. You can pick the first value and the second value, sum of that divided by the total variance, like summation of the covariance matrix. So this will tell you like how much percentage of variance of the original data is captured in first two principal components. Okay, so these are the steps involved. So I just wanted to explain you the mathematics of principal component analysis. Later I'll be uploading a few videos on how to implement these algorithms in Python also. Thank you guys for watching. Do like the video and subscribe to my